All right, problem 2, differentiate between a HTTP persistent and a non-persistent connection. Persistent connection uses one TPC connection for multiple request responses. A persistent connection remains open for a period of time after the request responses are completed. That period of time remains open based on the configuration and depends on how much time has elapsed since it was not used. If it's not used, then eventually it will stop. Because the persistent connection remains open, only one RTT is required to retrieve an object after the connection is started. A non-persistent connection requires a TCP connection for every request-response pair. The connection does not stay open for more than one object, thus requiring a 2 round trips every time an object is needed. One to initiate the connection with the server, and one RTT to collect the object. All right, problem 1. So how much time elapses from when a client clicks on the link to the client receives the object? So the IP address of the link is not cached in the local host. That requires a DNS lookup, which is necessary to obtain the IP address. To find the total time lapse, you'll need to find the sum of each RTT of each DNS lookup. So the problem gives us RTT0, 1 millisecond, RTT1, 6 millisecond, RTT2, 10 milliseconds. And the RTT for the HTTP request is 83 milliseconds. So the total time is 1 millisecond plus 6 milliseconds plus 10 milliseconds. And then we would need to make 2 round trips to collect the object. So 183 milliseconds total from the time the user clicks on the link, the DNS lookup is completed, and when the user receives the HTML object. Problem 2. So the time elapsed for receipt of the base object and 3 small objects, assuming a non-persistent connection and no parallel TCP connections. So 17 milliseconds are required for the DNS lookup, which is found in the previous problem. Once the host has the IP address, the client initiates a TCP connection with the server, which requires 1 round trip, so 166 milliseconds. The client then sends an HTTP request to the server. Server provides a response that requires another RTT. This process is completed for the 3 additional small objects. So in total, 681 milliseconds elapses once the user clicks on the link and to collect the HTML base object and the 3 small objects. All right, this one's similar to problem 2, but now we have 5 parallel connections. So we're going to find the time elapse with that consideration. So the total time would include the DNS lookup, which is 17 milliseconds. Since there are 5 parallel connections, a separate TCP connection is established for the base object and 3 small objects, allowing the objects to be received in the final RTT between the web server and the host. So there's an initial RTT to initiate the connection for each object, and then in the second RTT, the 5 parallel connections are utilized to return or provide a response with each respective object in their own separate connection. Total time elapsed is 349 milliseconds. Problem 4, find the time elapsed for receipt of the base object, 3 small objects, and now we're assuming a persistent connection and 5 parallel connections. So the DNS lookup is 17 milliseconds. So since there is a persistent connection this time, the TCP connections needed to receive the requested objects from the web server is set up on the first 2 RTTs. The third RTT is used to retrieve the requested object. So since there are 5 parallel connections and a total of 4 objects being requested, all objects are received in the third RTT.